Welcome to our series of PowerCore training videos. This video is called Advanced Engine Settings. From the home screen, we get into the menu by hitting the menu button and the correct passcode. And we toggle down to Advanced Engine Settings. Once it's highlighted, we hit the enter button and we're there. The first item is an address claim. This is for TSC throttling. It defaults to 3. A lot of engines default to 3, but you need to check with your engine folks to see what the address claim should be to send TSC throttling messages to the ECU. This number has to be correct for the ECU to pay attention to our speed commands. The ECU source address is almost always 0. If you have an ECU that has a different address than 0, this is where you would change that. ECU hours, it defaults to ECU hours. That means we get the running hour meter from the CAN bus. If you have an internal, if you have a mechanical engine, you would choose internal, and that way we would just go by run hours like we would with a mechanical engine. Crank attempts defaults to 3. This is how many times we're going to cycle crank. We're going to crank rest, crank rest, crank rest, and then we're going to go down on what they call an overcrank shutdown. This number can be increased or decreased depending on how many times you want to crank. Crank disconnect speed. This is how we do auto start. When the speed passes through 500 RPM, in this case, we turn the starter output off. You might want to raise or lower that if your starter's hanging in a little bit longer or not hanging in long enough. You can adjust this. Clutch engage speed and disengage speed. Okay, they work together. The two things have to happen for us to turn the clutch output on if you're using an external clutch engager like our CO3. You have to be through the warm-up delay and the speed has to have reached the clutch engage speed, and then we turn the clutch output on to engage the clutch. The clutch disengage speed, you have to be in cool down and the speed has to drop to that RPM set point before we turn the clutch output off, disengaging the clutch. Run to destruct is disabled. If you choose enable, then we ignore basically all shutdowns. I don't know when you would do this. You might do it if you have a fire pump or something and you don't care about the engine and the pump. You have the fire out. You could choose run to destruct, and there's no basic connect protection for it. Timers and delays. All your start delays, or most of the delays are in this section. There's a few delays that are in system. You have auto start delay, defaults to 3 seconds, auto stop delay, 3 seconds. These delays basically ignore an auto start or auto stop condition for that time delay. So if you had a condition that starts it, but you wanted to make sure the condition was valid through a delay, you would enter whatever time you thought it would be needed here for your start and for your stop. So it's going to ignore auto start and auto stop until that condition is there throughout this delay to make sure it's valid. Minimum run timer, if you put in, it defaults to 0, but whatever time you put into the minimum run timer and it gets an auto start, it's going to run for that time delay no matter if it gets an auto stop signal or not. So if you have a pump that, or an application where you say, once this engine starts, I want to run it at least for 30 minutes. I don't want to shut it right down again. This is where you would set that in. It's going to run for 30 minutes, even if it's calling for an auto stop. Stabilize delay, we turn that on to stabilize the ECU. So we make sure that we get valid CAN data from it. It goes through this on a shutdown. You'll see the stabilized timer come on just to make sure the ECU is stabilized. Crank time and rest time, that's the cycle cranking. They're set for 10 and 10. So we're going to crank for 10 seconds, rest for 10 seconds. Those can be changed. PreStart delay 1 and 2. This is for a pre-start function. This could be either for a glow plug, a preheat, pre-start warning horn, priming the pump, anytime you want an action done before we actually crank the engine. So we get the auto start signal, we're ready to go, and you want something to happen first. This is where you would set that. You have two modes on the PreStart 2 delay, PreCrank and crank through. PreCrank means that when the start signal is received, we turn on an output for the amount of time you put in the PreStart, and then when that time delay times out, we turn the output off and crank the engine. The crank through works the same way, except it keeps the output on until the engine actually starts. Energize to stop, used on fire pump applications, and that means that instead of energize to run, which is the standard config, where we put power out to either the ECU enable output or a fuel valve for a mechanical engine or a gas valve for a mechanical engine, energizing it to allow running, you can not put anything out and you energize to stop, which is typically on a fire pump. And this time delay means that that output's going to stay on after it, and when we call it to stop for that many seconds or minutes, so we don't run the battery down and leave it on forever until somebody comes out there. Spin down timer. If the engine starts up and shuts off, we go through a spin down timer before we allow the starter to re-engage. This makes sure that the pump is wound down, or whatever the application is, that the engine has actually come to a stop before we re-engage the starter, is all this is for. Post-crank lockout, that means in here we enter, it's set for 30 seconds. So you can assign different variables to this. This time delay starts timing when the cranking stops. When we reach that crank stop RPM, this time delay starts timing and locks out whatever you want locked out during startup. Low oil pressure for a mechanical engine is a factory default, and high water temperature is a factory default. So any variable you want locked out on startup, you would enter that variable here, and then you would change the time if you needed it to be different than 30 seconds. Post warm-up lockout, same idea, except for this time delay starts timing after the warm-up delay times out. This is typically used to lock out a low discharge pressure shutdown if the pump you're controlling is the only pump in the system. So if you have a single pump, center pivot, and it takes a while for that pump to develop pressure, it takes a while for it to get up to speed after warm-up times out, now we're actually up and running, you need to put a time, you need to assign low discharge pressure to this post warm-up lockout. So it allows the pump to get running, develop its own pressure, so we don't get a false shutdown and have to start all over again. The bubble lockout setup, anytime you have a variable that you want to ignore during normal run, like a little paddle switch on a flow meter, or something, or a float that for a low or high level shutdown is kind of bouncing, and you want to make sure it's made. You want to make sure that it's valid before you act on it. You can put a bubble timer in there and assign that variable to a bubble lockout. That way, if you have a minute in there, it's going to ignore that input for a minute. It's got to be there for a minute. If it leaves, it'll reset the time delay. So if it's just bouncing back and forth, the time delay will never time out. And that's what you want. You want it to be valid. You want it to be solid for a minute, then you know it's for sure something to act on. So that's what the bubble timer is for. Well, thank you. That concludes our video for advanced engine settings.